Okay, so today we're going to solve dot product of two sparse vectors. The question is that you're given two sparse vectors. These are one-dimensional vectors. These vectors could have non-zero values and zero values. Because they're sparse vectors, that means they have quite a large number of zero values generally. So our job is to compute the dot product of these two sparse vectors in an efficient manner. So let's see how we can do it. So the key essentially is that when you're given two sparse vectors and when you're trying to multiply them, or when you're trying to dot product them, anything that multiplies by 0 will give you 0. That's a huge thing that we can use. So if you see here, if 1 is multiplied with 0, you get a 0. 3 is multiplied with 0, you get a 0. So 0 multiplied by 0 is 0. 2 multiplied by 4 is the only thing that contributes to our resultant value. So the key here is that every time you encounter a 0 in your sparse vector, we should find a way to try to eliminate any kind of product or multiplication operation that occurs with this data element. So essentially what we are trying to do is that avoid all the zero based multiplication. So we will try to store non-zero elements and their corresponding indices in a data structure. Okay. So for now, let's just store it in a vector. So we have to store the non-zero element and the corresponding indices. We'll store the indices and the index and the element. So it's going to be vector pair int comma int. Let's say we're going to store all of our data in this kind of a data structure. Okay. So every time we have initialized a sparse vector object, we will store we will essentially in the constructor store all non-zero elements in this vector of pairs. So let's just complete this code for every non-zero element push index comma value into data. Okay. Now when we're trying to do the dot product of two object of sparse vectors, what we essentially just do is that we iterate through their data vectors, and if there are any matching indices, we will just multiply the values that correspond to these matching indices. Okay, so yeah, that's what we're going to do, and we will aggregate this into a sum and return sum. That's essentially what we're going to do. So here I will declare a vector int data for each object of a sparse vector. This will be its data variable or member variable, And when you're instantiating your data variable of the sparse vector object, you will take in the vector of integers and you will check if nums of I is now equal to 0. We will push it into our vector of pairs. So I'll create a pair with the index and then the value. Okay, that's done. Now, yeah, so we have to iterate for each of the sparse vectors. So I will use I and j to iterate our sparse vectors, and we will store the result in a variable called result. Now we will iterate for each of the vectors. We are instantiated object data dot size and j less than vector data size. If the indices match, so iterate through if there are any matching indices. Yeah, I of data of I dot first should match with vector data of j dot first. The indices match. We will store that prop. So data of I dot second times vector data j dot second. If they don't match or if one is less than the other, just increment the lower one. Yeah, if this is the last condition, data of I of first is greater than data of vector data of j of first, then you increment j plus plus. Then finally you return the result. Okay. So after every um, computation, also supposed to increment I and j. Yeah.